An asphalt highway cuts through a dense forest of spruce and birch. Beside it sits a gravel pull-off, a yellow provincial sign indicating a rest area, and a timber picnic table weathered gray by winter rain. Blue water shows through the trees under an overcast sky. A driver stops here, eats, and leaves without looking twice at the tree line. Then the ground underneath that asphalt drops 12 meters into an unmapped mine shaft. What seems like an unbroken wilderness is a surface pinned over structural voids, submerged ruins, and shifting geological boundaries. Millions drive across them, settle beside them, and construct infrastructure over them for generations, without registering the hazard until an instrument or a collapse forces the record open. How much of the map we rely on is simply an assumption waiting for the right trigger to break. Later, we will examine an entire municipality in British Columbia built, fully wired, and abandoned within 24 months, standing empty behind locked gates. And near the end, we will trace the deep tectonic rift along eastern river valleys that once reversed major waterways and remains overdue for a structural repeat. For over a century, the standard view of the Canadian landscape was one of immense stability. Solid granite, deep glacial till, and cold northern rivers were treated as permanent baselines. That assumption was built on early land surveys that mapped topsoil and timberlines rather than subterranean fractures. The first crack appeared when modern instruments looked beneath the surface. 35. The radioactive gas rising through granite floors. Across the Canadian Shield and Nova Scotia granites, bedrock continuously decays. As natural uranium in granite and shale breaks down, it releases radon-222, an odorless radioactive gas. The Geological Survey of Canada and Health Canada established that bedrock in regions like the Redding Prong Extension in Quebec and southwestern Nova Scotia generates gas that migrates through foundation microcracks. In closed basements during winter, concentrations frequently exceed national guidelines of 200 becquerels per cubic meter. It is the primary cause of lung cancer in non-smokers nationwide, yet property transfer regulations in most jurisdictions do not require mandatory testing prior to sale. 34. The town built over a subterranean labyrinth. Beneath Cobalt in northeastern Ontario, over 100 kilometers of abandoned mine shafts honeycomb silver-bearing conglomerate rock. Struck during railway construction in 1903, rich veins prompted underground development without modern structural pillar mapping. Over a century later, water filling unsupported voids dissolves remaining minerals while weakening fracture zones. In several locations, old timber caps under municipal roadways have rotted out, causing surface collapses that swallow pavement and utility lines into forgotten stopes tens of meters deep. 33. The disappearing rivers of the western karst. In the Crow's Nest Pass of Alberta and the Moline Valley in Jasper National Park, surface streams vanish into subsurface limestone networks. Dissolved over millennia by carbonic acid in groundwater, soluble Devonian limestone creates vast cave systems handling immense hydrological volumes. During peak spring snowmelt, underground channels reach maximum hydrostatic pressure, forcing water out of lower springs. A riverbed that appears bone dry in August can transform into a torrent rising several meters in under an hour when upstream runoff overwhelms subterranean capacity, flooding surface channels with zero atmospheric warning. 32. The sinkhole belts of Atlantic gypsum beds. In Windsor, Nova Scotia and western Newfoundland, bedrock consists of soluble gypsum and anhydrite. Unlike limestone, which requires centuries of acidic groundwater, gypsum dissolves rapidly in neutral water. In towns like Oxford, Nova Scotia, underground cavities expand continuously beneath residential neighborhoods. In 2018, a sinkhole opened in a municipal park, expanding to 35 meters in width and swallowing trees and paved paths as the cavern roof collapsed into the dissolved subsurface zone. 31. Spillway recalculations on major river dams. When the W.A.C. Bennett Dam was constructed on the Peace River in northeastern British Columbia in the late 1960s, crest height and spillway capacities were designed using historical flood data spanning less than half a century. In subsequent decades, Natural Resources Canada and provincial hydrologists re-evaluated extreme precipitation models and glacial melt rates under revised climate parameters. Updated calculations revealed that probable maximum flood events could generate inflows significantly higher than original structural assumptions, forcing multi-million-dollar engineering retrofits to auxiliary spillways to prevent water from overtopping earthfill structures. 30. The northward migration of vector-borne pathogens. The black-legged tick, Ixodes scapularis, was historically restricted to isolated pockets along southern Ontario and Quebec due to winter cold thresholds. Over the last 2 decades, Public Health Agency of Canada monitoring shows the species expanding northward at 35 to 40 kilometers per year into the boreal transition zone. The ticks carry Borrelia burgdorferi, the bacterium responsible for Lyme disease, altering the biological risk profile of forests across southern Manitoba, Ontario, Quebec, and the Maritimes, where outdoor recreation had operated without pathogen risk for generations. 29. Heavy metal legacy in shield waterways. Near Sudbury, Ontario, and along the watershed of Britannia Mine in Howe Sound, British Columbia, decades of ore extraction left massive tailing deposits exposed to rain and oxygen. This created acid rock drainage, where iron sulfide minerals react with water to produce sulfuric acid, leaching copper, nickel, and zinc into surrounding lakes and rivers. At Howe Sound, before a modern water treatment facility was installed at Britannia Beach, millions of liters of heavy metal-laden runoff poured daily into the marine ecosystem, rendering kilometers of coastal intertidal zone biological dead zones. 28. Endangered species starved by subterranean collapse. In karst systems beneath southern Ontario and the Maritimes, cave-dwelling organisms rely on energy inputs from above ground. Light does not enter these systems, so primary production is non-existent. In Ottawa Valley caves, large colonies of little brown bats, Myotis lucifagus, deposited guano that formed the base of the invertebrate food web. Since 2010, Pseudogymnoascus destructans, the fungus causing white nose syndrome, has reduced bat populations in eastern Canada by over 90% in monitored hibernacula. Guano deposits have ceased, causing a collapse in subterranean food chains that threatens specialized cave-adapted invertebrates found nowhere else. 27. Pristine surface water failing chemical standards. In agricultural regions of southwestern Ontario and the Fraser River Valley in British Columbia, groundwater discharging into surface streams appears completely clear. Clean appearance is a function of low suspended solids, which filtration through sandy till or fractured bedrock removes efficiently. Environment and Climate Change Canada research shows clear rural well water frequently contains nitrate concentrations above national drinking water limits of 10 milligrams per liter, alongside dissolved agricultural runoff. Physical filtering eliminates cloudiness while leaving dissolved chemical contaminants completely unaltered. 26. Inland straight-line wind events leveling mature forests. Across southern Manitoba and northwestern Ontario, severe thunderstorm complexes periodically generate derechos, widespread, long-lived straight-line windstorms. In July 1999, a massive derecho swept across the Boundary Waters and Quetico Provincial Park, generating wind gusts exceeding 140 kilometers per hour. The storm flattened over 200,000 hectares of mature forest in hours. Unlike tornadoes, which leave narrow paths, derechos produce continuous bands of straight-line blowdown hundreds of kilometers long, creating massive fuel loads for subsequent forest fires. 25. Hazardous atmospheric pockets in unventilated voids. In abandoned coal mines of Cape Breton, Nova Scotia, and natural limestone caves of the Alberta Rockies, gas displacement presents an invisible physical hazard. In unventilated passages, oxygen is routinely displaced by carbon dioxide or methane leaking from surrounding strata, creating lethal hypoxic zones known as black damp. Because carbon dioxide is denser than atmospheric air, it collects in low-lying chambers without visual or olfactory indications. Entry into these unmonitored spaces causes immediate loss of consciousness before an individual detects respiratory distress. 24. Historic accumulation of agricultural additives in bedrock. Throughout the late 20th century, organoarsenical compounds were added to commercial poultry feed across North America to promote growth. In intensive farming regions such as the Fraser Valley and southern Ontario, millions of tons of manure containing residual arsenic were spread annually over agricultural fields as fertilizer. Hydrogeological studies by Natural Resources Canada confirm that arsenic does not degrade. Instead, it binds to iron oxides in topsoil or leaches into shallow aquifers, where it remains mobile within local groundwater systems decades after feed additives were withdrawn. 23. Troglomorphic species losing functional optics during development. In subsurface aquatic ecosystems of Western Canada, subterranean fauna demonstrate extreme adaptations to perpetual darkness. Species like Stygobromus amphipods found in western aquifers are born without functional eyes or pigmentation. These organisms depend entirely on lateral line sensory systems to navigate groundwater channels. Because they are adapted strictly to stable, low-nutrient environments, any chemical or thermal disruption to the overlying aquifer triggers local extinction events long before surface monitoring detects water quality changes. 22. Historical meteorological events reshaping settlement patterns. On September 9, 1821, a violent tornado struck near the early settlement of York, now Toronto, Upper Canada, cutting a swath through virgin timber and clearing homesteads. Early 19th century records maintained by local archives document that severe convective storms caught early European settlers unprepared due to the lack of regional meteorological observation networks. The sheer scale of timber destruction altered early road placement and clearing strategies across the region for decades. 21. Municipal delays in public reporting of bacterial contamination. Along the shores of Lake Ontario and Lake Erie, public beaches face periodic closures due to elevated Escherichia coli counts, particularly following heavy rainfall that overwhelms municipal stormwater systems. In several historical instances during the early 2000s, water sampling protocols required 48 hours of laboratory incubation before bacterial thresholds could be confirmed. As a result, recreational beaches remained open to thousands of swimmers during summer weekends, while official water quality samples were actively incubating elevated contamination levels. 20. Dye tracing tests exposing unpredictable subsurface connections. To map groundwater flow paths through fractured limestone in the Kingston region of Ontario, hydrogeologists from Queen's University utilized fluorescent dye tracing. Injecting non-toxic tracer dyes into agricultural sinkholes, researchers tracked the dye as it emerged days later in municipal wells and shoreline springs several kilometers away. Results proved that subsurface fluid transport in fractured rock does not follow surface topography, demonstrating that contaminants spilled in one watershed can rapidly cross beneath regional boundaries and discharge into separate water supplies. 19. The fungal pathogen that decimated eastern bat populations. White nose syndrome, caused by Pseudogymnoascus destructans, was first recorded in North America near Albany, New York in 2006, likely introduced by human visitors carrying spores from European caves. By 2010, the pathogen crossed into Ontario, Quebec, and New Brunswick, infecting hibernating bats during winter torpor. The fungus grows on exposed skin, causing bats to awaken prematurely, exhaust fat reserves, and starve before spring. The Canadian Wildlife Federation estimates that over 99% of little brown bats in infected eastern hibernacula died within 4 years of arrival. 18. Ice storms collapsing electrical distribution infrastructure. In January 1998, a persistent weather pattern locked a warm, moisture-laden air mass over a cold surface layer across eastern Ontario, southern Quebec, and southern New Brunswick. Over 80 millimeters of freezing rain fell over 5 consecutive days, coating trees, roads, and power infrastructure in thick ice. The sheer weight collapsed over 1,000 transmission towers and 35,000 utility poles, leaving over 4 million people without electrical power in sub-zero temperatures. The event demonstrated the extreme vulnerability of modern surface infrastructure to sustained icing conditions. 17. Cold War military legacies on remote northern ranges. During the height of the Cold War, weapons testing across remote regions of Canada left significant hazardous legacies. At testing facilities like former military ranges in Alberta and Manitoba, experimental ordnance and rocket propellants were deployed over wide areas. Unexploded ordnance remains buried in soil and sediment across these retired sites, requiring ongoing monitoring and specialized clearance operations by the Department of National Defense to prevent environmental leaching and accidental detonation. 16. Agricultural runoff conflicts adjacent to protected waterways. Along the margins of Point Pelee National Park and the Grand River watershed in southwestern Ontario, intensive agricultural land use directly borders protected natural zones. Agricultural drainage tiles route nutrient-rich runoff, heavy in nitrogen and phosphorus, directly into wetlands and stream networks. This sustained nutrient input triggers severe seasonal algal blooms, depleting dissolved oxygen levels and threatening aquatic life within protected boundaries that were established under the assumption that geographical lines on a map would shield ecosystems from surrounding industrial activity. 15. Return of apex predators to historical ranges. Across southern and central Ontario, sightings of eastern cougars and re-established wolf-coyote hybrids have increased over recent decades. Historical records show that large apex predators were virtually extirpated from southern agricultural zones by the early 20th century through bounty systems and habitat fragmentation. Field data and remote camera monitoring by provincial wildlife biologists confirm that these predators are increasingly utilizing regenerated forest corridors and abandoned rail lines to recolonize regions where they had been officially listed as extirpated for over a century. 14. Historical prohibitions on severe weather terminology. For decades in the early 20th century, official weather forecasting policies in North America strictly restricted the use of the word tornado in public advisories. Meteorological agencies operated under the assumption that issuing explicit tornado warnings would cause widespread public panic that outweighed the risk of the storm itself. Consequently, severe convective storms capable of producing destructive funnels were routinely reported merely as severe thunderstorms, leaving communities without explicit warnings until visual contact was made. 13. Specialized cave ecosystems threatened by surface land use. In the Crow's Nest Pass area of Alberta, Booming Ice Chasm contains unique subterranean ice formations and microclimate conditions developed over thousands of years. The structural integrity and thermal balance of such deep alpine caves depend directly on the hydrological regime of the mountain surface above. Forestry operations, road construction, or surface quarrying alter surface water infiltration rates, introducing sediment and changing temperatures within fragile underground ice structures housing unstudied cold-adapted biological communities. 12. Historical chemical contamination of northern industrial communities. In the mid-20th century, industrial production in several northern resource towns generated significant localized environmental contamination. In places like Deloro, Ontario, decades of mining and smelting arsenical gold ore left high concentrations of arsenic, heavy metals, and low-level radioactive waste scattered across the town site and local riverbanks. Remediation efforts by provincial authorities required excavating thousands of tons of contaminated soil and constructing long-term containment vaults to isolate toxic residues from the surrounding watershed. 11. Thermotolerant pathogens expanding in northern lakes. Naegleria fowleri, a thermophilic amoeba causing primary amoebic meningoencephalitis, thrives in warm, untreated freshwater when temperatures exceed 30 degrees Celsius. Historically restricted to southern climates, water temperature monitoring across southern lakes indicates that extended heat waves are creating temporary thermal niches capable of supporting thermotolerant organisms. While confirmed cases in Canada remain extremely rare, changing thermal profiles in shallow, closed lake basins present shifting ecological conditions for microscopic aquatic organisms. 10. Violent tornadoes reshaping modern urban disaster planning. On July 31, 1987, a devastating F4 tornado struck Edmonton, Alberta, with winds reaching 400 kilometers per hour. The storm remained on the ground for over an hour, killing 27 people and causing over $300 million in damage. The event exposed critical gaps in regional emergency broadcast systems and led directly to the development of Canada's National Modern Weather Radar Network and automated public alert infrastructure. How did these isolated geological and environmental hazards remain uncoordinated on official maps for so long? 9. Invasive species mapped across vast boreal ecosystems. In ecosystems where wild boar cross border corridors, feral swine populations are tracked using thermal airborne imaging and environmental DNA sampling. Researchers from Natural Resources Canada and provincial wildlife agencies collect water samples from forest streams, filtering them for trace shed cellular material. The eDNA analysis detects wild pig presence within a river system days before physical sign or trail camera footage confirms movement, proving invasive populations expand into watersheds long before traditional ground surveillance registers their arrival. 8. Historical transit corridors reconstructed from archival field notes. Along historical routes of forced migrations and early resource trails in eastern and western Canada, physical evidence of 19th century transit was long obscured by vegetation growth and modern road construction. Researchers from the Canadian Museum of History and provincial archivists re-examined handwritten surveyor fieldbooks from the 1830s, cross-referencing chain measurements with high-resolution airborne lidar data. Digital terrain models stripped away modern forest cover to reveal actual rutted wagon paths, original timber corduroy roadbeds, and unmarked burial alignments that satellite imagery could never detect. 7. Subsurface chemical detection beneath active military reservations. At CFB Petawawa in Ontario and CFB Shiloh in Manitoba, environmental scientists from Defence Research and Development Canada mapped groundwater contamination using monitoring wells and mass spectrometry. By analyzing core samples and groundwater drawn from varying depths across the bases, researchers identified plumes of per- and polyfluoroalkyl substances, known as PFAS, originating from historical firefighting foam burn pits used since the 1970s. Hydrogeological modeling demonstrated that dissolved fluorinated compounds were migrating through permeable glacial outwash sand directly toward regional river systems. 6. Guerrilla warfare legacies preserved in historical cadastral maps. In regions affected by 19th century border conflicts and local rebellions, such as the Niagara Peninsula and the eastern townships of Quebec, historical property lines and abandoned defensive works were documented through cadastral surveys executed between 1812 and 1838. By overlaying early British ordnance maps with modern satellite magnetometry, geophysicists identified subsurface magnetic anomalies representing buried iron ordnance, homestead foundations destroyed during raid events, and concealed weapons caches along historical patrol corridors. 5. Structural failure modeling of fluid reservoirs. At pump storage hydroelectric facilities across North America, structural integrity was historically monitored using surface-level sensors. On December 14, 2005, when the upper reservoir wall collapsed at Tom Sauk in Missouri, sending over 5 billion liters of water down Prophet Mountain, post-failure investigation by civil engineers utilized side-scan sonar, laser scanning of the failed crest, and forensic core drilling. Scientific data proved that unanchored geomembrane liners had displaced internal water level sensors, sending false normal readings to control systems, while water actively overtopped the rock-filled dike. 4. Historical vigilante movements reconstructed from archival court dockets. In the late 19th century, rural enforcement networks operating across remote agricultural frontiers left few official records. Historians analyzing early judicial archives in Ontario and the Maritimes uncovered handwritten witness depositions and coroner inquest files from the 1880s. By cross-referencing these historical documents with land registry titles, researchers mapped how local vigilante groups used masked intimidation to control land transfers and alter municipal governance patterns across isolated rural townships. 3. Industrial dioxin contamination identified by soil core mass spectrometry. At historic wood treatment facilities across Canada, such as those in Thunder Bay, Ontario, and contaminated river sites like Times Beach, Missouri, dioxin contamination was confirmed using gas chromatography mass spectrometry. Soil cores revealed 2, 3, 7, 8 tetrachlorodibenzo P-dioxin concentrations exceeding 100 parts per billion, far above safe residential thresholds. Hydrogeological sediment sampling proved that seasonal flooding mobilized the hydrophobic compound, binding it to river silt and spreading toxic residues throughout downstream floodplains. 2. Drowned towns mapped by multi-beam bathymetry. Beneath artificial reservoirs created by major hydro projects, such as the St. Lawrence Seaway's Lost Villages flooded in 1958, hydrographers from the Canadian Hydrographic Service use high-resolution multi-beam echo sounders. Acoustic returns construct detailed three-dimensional bathymetric maps of the lake floor, rendering submerged concrete foundations, intact bridge abutments, and former highway alignments visible through the water column with centimeter-level precision. 1. Paleoseismic verification of major intraplate fault zones. Along the St. Lawrence Rift System and the Ottawa-Bonnechere Graben, paleoseismologists from the Geological Survey of Canada identified evidence of prehistoric mega-earthquakes using trenching and acoustic seismic reflection profiling. By excavating trenches across post-glacial fault scarps, geologists uncovered liquefied sand dikes and displaced glacial-marine clay layers. Radiocarbon dating of organic material trapped within these deformed sediment beds proved intraplate fault zones across eastern Canada have repeatedly produced earthquakes exceeding magnitude 7 over the past 10,000 years. What happens when these hidden structural anomalies meet modern environmental stresses? Today, these hidden forces dictate the structural and economic realities of regions built over them, imposing massive, open-ended costs on governments and local populations. The hazards do not resolve themselves. They simply require perpetual management. For properties built over the uraniferous granite of the Canadian Shield and the Maritimes, radon mitigation is an inescapable architectural requirement. In Nova Scotia and New Brunswick, modern building codes mandate sub-slab depressurization systems in new residential construction. Retrofitting existing homes costs property owners between $2,000 and $4,000 per structure. Health Canada estimates that radon exposure causes over 3,000 lung cancer deaths annually across the country, primarily because testing remains voluntary in existing real estate transactions, leaving thousands of rural basements unmonitored. Abandoned stopes beneath Cobalt, Ontario require continuous municipal surveillance. The provincial government manages an ongoing crown pillar assessment program, drilling boreholes to gauge the remaining thickness of rock between the surface and flooded mine voids. When a pillar is deemed structurally deficient, sections of provincial highway or municipal road must be closed and bridged with reinforced concrete caps, or voids must be backfilled with cement grout at public expense. The town remains permanently constrained by the geometry of tunnels excavated a century ago. In karst regions of western Newfoundland and Nova Scotia, sinkhole development dictates municipal zoning. Geotechnical surveys utilizing ground-penetrating radar are required before new commercial or residential foundations can be approved in high-risk zones. In Oxford, Nova Scotia, the 2018 sinkhole expansion forced permanent closure of the municipal park and surrounding commercial structures. The cost of stabilizing the immediate perimeter exceeded $1 million, and geological monitoring confirms underground dissolution of gypsum bedrock is ongoing. Complete structural failure of surrounding residential blocks remains a quantifiable, localized risk. At the WAC Bennett Dam in British Columbia, BC Hydro completed a $500 million upgrade to spillway infrastructure in the 2000s to manage revised probable maximum flood models. Retrofits included reinforcing spillway chutes and installing post-tensioned anchors deep into bedrock to prevent structural shearing during extreme discharge events. Despite these upgrades, the dam requires constant seismic and hydrological monitoring, as failure of the earthfill structure would catastrophically inundate the Peace River Valley, threatening municipal infrastructure of Hudson's Hope and Taylor downstream. The expansion of the black-legged tick into the boreal transition zone forced permanent alteration in public health protocols and land use. Provincial health ministries in Manitoba, Ontario, and Quebec dedicate millions of dollars annually to Lyme disease surveillance and prophylactic antibiotic distribution. Forestry workers, line crews, and agricultural laborers in these regions face an occupational hazard that did not exist 30 years ago. The biological baseline of the southern Canadian forest has fundamentally shifted. At the Britannia mine site in British Columbia, heavy metal contamination of Howe Sound is managed by a high-density sludge water treatment plant constructed by the provincial government in 2005. The facility processes over 4 billion liters of acid rock drainage annually, neutralizing sulfuric acid and precipitating heavy metals into solid sludge before discharging treated water into the ocean. The plant costs approximately $3 million per year to operate and must run in perpetuity, as chemical reactions within abandoned mine workings cannot be stopped. The collapse of cave ecosystems due to white nose syndrome removed a critical biological control from eastern agricultural regions. The loss of millions of insectivorous little brown bats forced agricultural producers in Ontario and Quebec to increase chemical pesticide application to control crop-damaging insects. The Canadian Wildlife Health Cooperative notes that while some small remnant bat populations show signs of resistance, the sheer biomass of lost colonies cannot be replaced in the near term, transferring the economic cost of pest control directly onto local farmers. Residual organoarsenicals in agricultural watersheds require strict groundwater monitoring by rural municipalities. In the Fraser Valley, municipal wells drawing from shallow aquifers must be routinely tested for arsenic and nitrate concentrations. When thresholds are exceeded, municipalities are forced to install expensive reverse osmosis filtration systems or drill deeper wells into confined aquifers, passing capital and maintenance costs onto rural ratepayers. The legacy of a discontinued agricultural additive continues to dictate operational budgets of local water utilities. At CFB Petawawa and CFB Shiloh, the Department of National Defense conducts ongoing environmental remediation to manage PFAS plumes. The military installed active groundwater extraction and carbon filtration systems at plume edges to intercept fluorinated compounds before they discharge into local rivers. Remediation is projected to take decades, and the total cost of managing PFAS contamination across federal properties in Canada is estimated by the Treasury Board to exceed hundreds of millions of dollars. The chemicals do not break down in the environment, meaning extraction must run continuously to prevent downstream migration. For communities situated along the St. Lawrence Rift system, paleoseismic evidence of prehistoric mega-earthquakes directly dictates modern engineering standards. The National Building Code of Canada designates the region from Montreal to Quebec City as a high seismic hazard zone. Modern infrastructure, from hospital complexes to highway overpasses, must be designed to withstand significant lateral acceleration. Upgrading older, unreinforced masonry buildings in historic districts remains a multi-billion-dollar challenge. The geological record proves the fault system is active. The current period of seismic quiet is merely the accumulation of stress before the next inevitable rupture. These hidden hazards demand constant vigilance and perpetual funding. But what is the final cost of living on a landscape that is fundamentally unstable? 4. The ghost town preserved intact in the northern wilderness. Kitsault, located at the head of Alice Arm in northwestern British Columbia, was constructed in 1979 as a modern mining community for over 1,200 residents, complete with housing, shopping centers, and municipal infrastructure. When molybdenum prices collapsed in 1982, the mine shut down after 18 months of operation. The entire town was evacuated, locked behind gates, and maintained in complete isolation for 4 decades. It stands today as a fully intact, uninhabited modern urban footprint preserved in the coastal rainforest. 3. Communities erased by environmental contamination. In Canada, localized industrial contamination forced the abandonment of historic sites, such as the village of Deloro, Ontario, where arsenical gold processing left soil levels so hazardous that the province bought out properties, fenced off the town site, and constructed long-term hazardous waste vaults over former residential blocks, mirroring high-profile chemical relocations elsewhere in North America. 2. Submerged communities lying beneath hydro reservoirs. Beneath the waters of Lake St. Lawrence lie the Lost Villages, 9 communities flooded in 1958 during construction of the St. Lawrence Seaway and Moses Saunders Power Dam. Over 6,000 people were displaced, and entire villages, rail lines, and highways were submerged. Today, when water levels drop during low flow periods, submerged concrete foundations, canal locks, and old survey lines remain clearly visible through the water column, preserved beneath a working commercial shipping channel. 1. The intraplate fault zone capable of devastating national infrastructure. Running directly beneath the St. Lawrence River Valley is the St. Lawrence Rift system. Paleoseismic trenching and marine seismic reflection profiles conducted by the Geological Survey of Canada prove that this intraplate fault zone generated massive earthquakes in 1663 and 1870, reaching estimated magnitudes above 7. The fault system remains seismically active today, sitting directly beneath the industrial and political core of Quebec and eastern Ontario, where millions live on unreinforced post-glacial marine clays that amplify seismic ground motion. What kept these anomalies hidden for so long was not their depth or remoteness, but the assumption that an official survey map sheet represents a complete and finished record of the terrain. Unmapped mine voids continue to settle, heavy metal plumes migrate through unseen aquifers, and intraplate faults silently accumulate strain beneath our largest transportation corridors. The map sheet looks complete, but the ground underneath it is still moving. Which place in your own province or territory has always struck you as geologically odd or historically out of place? Share your thoughts in the comments below, and consider subscribing to stay informed on the hidden geography shaping our landscape.